Hello and welcome to PyRVA. I'm Chris May. I'm your host for tonight, one of the co-founders of PyRVA, and here we are at our monthly lecture night. I was hoping to have this other slide come up, but that's okay. Welcome. I see that we have a few live streamers here on YouTube, and I was just chatting with some people on Discord. This is what I wanted to get to. Any one of you who are live on YouTube, definitely join us on Discord. We will continue the discussion after the lecture is over on Discord, and Tanim's gonna hang out and talk to us a little bit more and share his wisdom with us. Yeah, I'm pretty excited to see what he's going to talk to us about, and hopefully this will work. Nope, that didn't work. Sorry about that. Try to hot swap things in the middle of the meeting, and it doesn't always work. All right. Oh. Oh, that's why. Sorry about that. Well, we'll just share it anyway. Do it live, right? Sorry, everybody. I'm trying to share my screen again, and it is not having it's not happy to do that. Okay, well, it seems like that's not going to work tonight. Unfortunately, for some reason, I cannot share a different screen. So let me just do our notes for this meeting on my tab. So let's start off with YouTube and Discord. As you can tell, we are live on YouTube, and thanks for joining us. As I mentioned before, Discord is where we're doing most of our online engagement. Some of us kind of hang out there every now and then. It's a great place. There's Slack, but we've been finding Discord is a great place to like collaborate into you can grab a couple people and get into a room and kind of discuss things a little bit, both on audio and video, or just in text. Either way, we are going to be in there immediately after the lecture to just talk, see what comes up. We just hope that you'll join us in there. Next, we are also going to have, there are a couple events that are coming up. We have a coding night coming up at the end of the month in July 23rd. Check it out on Meetup for more details. In addition, on August 20th, we have the privilege of joining RVA Tech for a presentation. I believe it's a webinar. We don't have the details yet exactly of where that is or how to connect to it, but we will be in the next couple of weeks. So put that down on your calendar, and hope you come and check it out. And finally, one more thing is we also are going to have a Pycharm license to give away, which is really wonderful because JetBrains does an amazing job making Pycharm. It's my favorite Python editing environment. VS Code is great too. But man, if I need to get stuff done, I go to Pycharm, and I'm just so very happy that JetBrains is giving us a free license to give away. So you'll have to join us in Discord after the lecture to get a chance to win that. In the now, without further ado, let me introduce Tanim Islam. He's a physicist who works at Lawrence Livermore Labs in the Bay Area in California. He's been working there for, I believe he said he was working there for 9 years. He uses Python all the time, and he was originally from Richmond, Virginia, which is incredible that he's gone all the way out to California and is back to join us tonight. So Tanim, I'll turn it over to you.
All right, thanks there, Chris. So I'm going to, I guess, share the whole screen because I envision hopping between the presentation as well as coding exercises. So here's the presentation here. When I'm going to talk to that, it's going to be full screen. And there's going to be demonstrations on the GitHub page, specifically in this demonstrations directory that you guys can follow on with me if maybe the screen is not as clear. So with that, I guess, can everybody hear me okay? Chris, is everybody saying the sound is good? Okay.
I'm not seeing anybody saying that it's not working. So I say go for it.
All right, let's go for it. So let me do it to it. Presentation is about, well, here's the presentation title, Python for quick, useful multimedia manipulation. Anecdotes from a Python programmer. So it's basically, I'm going to discuss 4 sets of tools that I use all the time, both in work and play, for my day-to-day work and, you know, when I want to unwind. The last one is the one that's sort of more complicated, but its functionality is still similarly as straightforward as the other ones. So with that, basically what this talk is about, who am I? I make and manipulate lots of images and videos in my day-to-day work. A big chunk of my time is not only devoted to research and evaluation, but also presentation. And with that, I found out, or I just got lazy enough to spend some time to develop some tools to basically smarten up images and create nicer videos than what was available before, because I have to make lots of images, or I have to redo lots of images for various say figures that I've got to put into papers, presentations, posters, this and that. I think I do about 1 presentation a week on average now. So these are the 4 things I'm going to show, demonstrate in this talk. Auto-cropping images, videos from a collection of images, creating animated GIFs, because some of these services that I use, like GitHub or Read the Docs, they don't allow you to, you know, actually animate a video that you upload to their, at least the documentation part of the service, but they do allow animated GIFs. And I guess since the one of the tools that I thought was working didn't work because the service Cloud Convert sort of went away, I'm also going to talk into a little detail about something that I use to just sort of a novelty tool, but you can take metadata from one place, MusicBrainz, and the song which exists on YouTube to put into a fully metadata populated song that sits on your hard drive. So also, I should have brought this up before. Well, let me go back. The way I work best if, you know, if people have questions or want to go on tangents or, you know, elaborations on any point that I'm talking about, or even something that's only tangentially related, please chime in. That's sort of the best way I know that I'm reaching people and at least gearing the presentation I'm making to what people actually find interesting. So there are 4 places where I either take the examples or where these tools live. There's a GIF that I made that just for this presentation, where it takes a sequence of images, in this case, PNG files, and creates an Mp4 movie from it. There's also 3 other GitHub repos that I have. NPR Stuff, which is a grab bag of tools that I developed to download, you know, NPR podcasts, which ironically no longer works. And on top of that, I created other tools for image and video manipulation. COVID-19 stats, one of the things that I hacked together hobby-wise starting in March and April was something that takes the New York Times database and creates, to me, nice sort of succinct video and image visualizations of the data. and this other thing that, well, I can talk about later. So the first thing I'm going to talk about is auto-cropping images. So like, show of hands, well, you can chime in. I find that a lot of the images I find, these could either be lossy or vector image formats like PDF or PNG. A big problem with them is that they don't come born cropped. They have a lot of white space around it. And if you try to, put this image into a presentation or a paper, what have you, you have a problem. Either you have to manually, shoehorn in the bounding box yourself, or just live with it and deal with a lot of wasted real estate. So I found like a few years ago that I did this. I've been doing this for decades, but I figured out there must be a better way. And that was, at least in Python, to create a tool that would automatically crop out the white space of both PDFs as well as lossy image formats like JPEG, PNG, TIFF, and what have you. So just going to that, I'm going to describe the code here a little more deeply, because at least this code, the thing that implements this functionality, is pretty conceptually simple. You take an image that has, say, a lot of white space around it, and there's a Python, function called imread. It's part of the matplotlib module. If you guys are familiar with that, that's sort of the like this world-class Python module for making plots and figures. There's a functionality called imread, wherein you can load in a lossy image, which will, create a NumPy array of that data. The coordinates of that 2D NumPy array are just the X and Y pixel coordinates, and those values are, of course, if it's a color image, they're the RGB alpha values there. The tool that I have, and actually the actual, functionality, the Python function that I have, just finds the first and last X and Y coordinates that are white, or rather the first and last coordinates that are not white, finds them, and that's automatically your bounding box. And then with Python functionality there, crops that image and either saves it to a new file, or by default, if you don't specify another file name, it'll save it into the same file. So let me just pop on that functionality there. So is everybody okay following me so far? Okay, I assume so. So let's just go through it. There are really just two methods that I have that demonstrate that functionality. Oh, the first is, making the lossy image here. And I want to point out to a bunch of this stuff, it's basically something called the Python image library, wherein you can actually load in an image and do image manipulation. And this is just stuff to say, okay, dealing with if you want white or if you don't want white as your background color. This one here, yes?
Would you be able to make your text larger?
Oh, sorry. You want to use it or not?
Well, I was just thinking if you make the text larger, we'll be able to see it a little bit better.
Oh, okay, sure. I'll make it. Is this a lot better?
Yeah, I think so. Thank you.
Okay. All right. So two things. This thing is just, okay, load in this image and do stuff with it. This other stuff is, okay, independently, load in this image as a NumPy array, 2D NumPy array with values. And then this part is really the conceptual meat of it. It just says, NumPy is, a great bit of tooling that allows a lot of, vector algebra on large numerical data sets like vectors and matrices. But it has functionalities. This is actually a surprisingly fast bit of functionality that all it says is a high level is tell me all the, pixel coordinates where the where the thing is not the background color. And as you can see, as you'll find out in other code that I show, I tend to editorialize, especially where I see some illogical or poor functionality that I have to work around. So that's all this is. And you just look for the leftmost and rightmost and uppermost and lowermost, and that's your bounding box. And you showed that this is this is just the functionality of the Python image library. You have this image object, you just crop it. And that's really basically it. And I'll just demonstrate this part here. So let me just go through that. So I guess I'll make this bigger too, so that it's also easier to see.
Thank you.
Can everybody see this okay, or should I make it a little bigger?
Maybe one step bigger.
Okay. All right, and I'll just make it smaller. All right, so maybe you might not exactly believe me, so I'll just delete that. So we're just going to regenerate this. So now you see two files. The first one that was, initially the input, and the last one, which is the output, which is nominally the crop one. And I'm just going to open it up. Hopefully this will work. Yep. All right. And let me show the uncropped, cropped. And I use this functionality all the time. Now the second one is actually, I'm not going to go into a lot of details there because technically speaking, I lifted with attribution a lot of the code. But at a high level, all it does is it uses my Python module called PyPDF2 to do the PDF manipulation, reading, manipulating in, and writing out of a PDF file. In this case, a PDF image. And at a low level, it uses through Python subprocess, does command line calls to a tool called Adobe Ghostscript, which you might know PDFs and PostScript files are formats that are developed in the developed by Adobe as PostScript files. PostScript is actually a language, and this PostScript tool, Ghostscript, actually can do low-level manipulation of that data. In this case, what the Ghostscript syntax does is it tries to find the automatic bounding box of this PDF, the part that is, not white in this case, and then uses PyPDF2 to crop that image. And I'm just going to show you a demonstration of just one of those, kinds of PDF plots that I, make a lot, say with Matplotlib for my day-to-day work. But, I need to crop it to, say, put it into some kind of presentation. So let me go back to that one again. Well, let's go the same workflow as before. Gonna close that up. And let me go here. Is this functionality that I have right here, which is really the stuff that I use to, create a cropped, auto-crop PDF file. So there's, and I confess, full disclosure, this is functionality that I did lift, hopefully with sufficient attribution from somebody's GIFs to put into this code. But the important parts of this functionality is part that says read this in. First, get the bounding box. Of course, read that file in, apply, and I'm guessing basically apply the bounding box to that PDF object that I've read in, and then write that out. And the part that says, okay, calculate the bounding box is this bit of, to me, voodoo magic that that's done with GhostScript. And to be honest, I don't quite know how it works. I just know it works. I can verify that it does what I need it to do. So if you want me to give you more details about what that does, unfortunately, I don't know enough about GhostScript to tell you what it might do. But I can demonstrate that this tool does behave how I expect it to behave. So can you guys see everything here on the screen?
I believe so.
Okay.
Can't say for sure, but we can definitely see the screen.
All right. All right. So that's that. And hopefully this will open it in this actual workspace. Oh, of course not. It would pop into someplace else. But this is the uncropped image. You can see the significant amount of white space around it. And here's the crop one. Just at least it's good enough for me. Everything, it has actually no no wasted white space. It's anywhere from the non-white to the non-white parts, both horizontally and vertically. That's, I guess, demonstration number one. Since we have 2 hours to go through, I guess now's the time I can pause for any questions that people might have.
There are no questions yet, but
okay.
But I'll let you know when there are some.
Okay. All right. All right. So I guess I could move to the next one that I have right now. All righty. Let me just hop to. Okay. And of course, this is the syntax. It uses argument parser to just define exactly what you want to do. I showed the default operation with one wrinkle being specifying an output file. But if you don't, it would of course clobber. It would clobber the file you gave it. The default color is white. It also has the ability to to deal with transparencies in lossy images, as well as rescale if you want your new figure or image to be a different size. It does it by the width you specify in pixels. And the last one, I guess I could have used it, but it's easier just to show the output. There's a way it works best. I've seen on Macs is it'll show, basically use a default viewer to, show the output. Okay. This next one is creating movies from a sequence of images. So there's, of course, tooling around the internet to do that for you. There are online services and so on and so forth. And at a low level, the tools here use this very powerful multimedia, I guess. It's really an SDK because it consists of an API as well as command line tools, and it's called FFmpeg. I don't know how many of you are familiar with that, but it's basically the workhorse engine behind conceivably almost every multimedia hardware and software solution out there for reading in and converting audio and audio visual data files from one format to the other. It also has the capability to do streaming too. So there's a tool that I have that I've developed just for this presentation. It's also in this GitHub repository, and it's also a custom public gist on my GitHub page. So this creating movies is split into two parts. The first part is creating an MP4 file from a sequence of images. And the second is creating an animated GIF from either a YouTube clip or an MP4 file. And as I explained, it uses at a low level the tool FFmpeg and does basically command line calls through Python subprocess to basically make all that happen. So the first example is a presentation I gave to some high school students at Maggie Walker, I think 2 years ago, about a concept called Monte Carlo multi-chain or Markov chain Monte Carlo. Sorry, I really should know this because I use it all the time. It's basically a way of saying if you have an arbitrary distribution function that's arbitrarily complicated, you don't need a formulaic expression of it. You can just use the raw properties of that distribution function and use this algorithm to naturally sample from it. And the idea was, okay, a grayscale image of myself is this distribution function. Like black is most likely, white is 0 probability. And this was a demonstration of MCMC, from a few particles to as many as I think 10 million, frames 1 to 255, just filling that out. Now the way this, images from a sequence of images to MP4 files, the way it works is it's probably a restriction of, I think, the encoder that's used, or maybe the limitations of the specification for MP4, but the width and height of every image has to be divisible by 2. So I'll just show this here. The default frame rate is 5 frames per second, so it would take probably 30 seconds to do, which is good enough for a screensaver, but probably not good enough for a presentation. And let me just, at least at this point, there's another example I'll show, which also goes through the same thing, but I'll just go through a demonstration of the code as well as its functionality. So this is demonstration number 2. This is both a gist as well as something that lives in this presentation GitHub repo. But at a low level, it just says identify. Well, first, make sure you have FFmpeg. Make sure your inputs and outputs make sense, and the settings make sense. The frames per second has to be greater than or equal to 1. And this is just logic to check all the images that are the same. What exactly are the image files? And okay, create the goofy syntax, I should say, to actually send to FFmpeg to create the MP4 file. Go through all that stuff, and then create that image. So I should mention that this, I'm not really being incredibly original with all this. A lot of the tools I make are thin wrappers over functionality that other people have already created or worked out for themselves. So I should point out this complicated syntax that I describe here follows something that's, from this website I found, which is basically, I found it works very well in basically all the cases I've done. Something like, okay, here's the, collect sequence of images, here's the file, and I just copy all the other settings except, I think, change the frames per second to, whatever is more comfortable for me. But the other ones, are just copied straight out from, this how-to. And so to demonstrate this one, let me just go to the next one. So let me see how I did it. Okay. Let's see. And let me go to that presentation because or actually it's in this file here. Let me go back. Yes. It's all this complicated stuff. So the first demonstration I gave was, okay, this MCMC, Markov chain multi-Carlo, is going through that, and I'll just show you. This is about, I think, oh yeah, 80 megabytes in size, because each file is above 360K. Each PNG is above 360K, and there's 256 of them. So it adds up. But out of all that, you create this thing here, and which is really the same thing I showed before. And I guess I could stop it right there because you've already seen it. The second example that I have here is, let's go through it. It's, in this case, I have this COVID-19 statistics GitHub repo. The links are both in this presentation and as well as in the demonstration. But the image that I'm demonstrating, or the movie I'm demonstrating for you, is a video of the cumulative COVID-19 cases for the continental US from the first case in the CONUS to July 4th. I actually have this tool that runs every day to regenerate, basically repopulate the New York Times database and create a bunch of summary statistics, one of which is the cumulative cases for 9 places, the CONUS and 8 separate metropolitan statistical areas. This is just the file here. The way this tool actually works is it doesn't use this GIST, to generate it. I actually have the, low-level functionality sort of inline in my code to generate these plots from, the data I collect in a pandas data frame, as well as the geographical data that I have from other data sources. But yeah, that's it in a nutshell, and I could just show the same thing here. Just demonstrate that. In this case, yeah, it's going at, I know it's there's a lot of details here, but it's just saying, okay, what sort of, there's a prefix, there's an output file name, the dir name to look at. Oops. Ooh, there's actually a bug in there. Just to do that for you. And I guess, and voila. I guess it only takes, well, 33 seconds. But I guess it is a visualization. Actually, one of the places I collect summary statistics on is the Richmond metropolitan area, which I think is in the GitHub repo, but for I think 2 weeks ago.
When you create these images or these videos, do the images have to be sequentially numbered for the script to make it correctly?
That's the way it has to work. As you can see here, like in this directory, you see they share a common prefix, right? And then the numbering has to be sequential. It has to have some logical ordering to them. The convention, I think the requirement is only that they increase, but the convention is, it's increment by 1. I haven't seen it be anything other than that. So, it could start from 000 or the lowest number out to a maximum number.
Thank you.
Yeah. Actually, there's also, let's see if there's also, hopefully this will work. Yeah, it'll actually tell you the name of the full, it's kind of hard to see here, but this is the full, command line syntax to generate, the MP4 file from the images in that specific directory. So it just, this -image2 f-image2-i is this sort of, C syntax string format to specify, okay, just look for, images in sequence with, three pads, a decimal number with 3 pads in it. So it's 3 digits, 0 padding. It's anywhere from 000 up all the way to, in this case, it could be 999, but just the maximum one. That's what it looked for. And yeah, that's if you're curious about exactly what went in there. This is what went in there. I guess I could also stop here. Am I going too quickly? Are there any questions? Anything else people want to know about this stuff?
Seems like everybody's following along at the moment.
Okay.
I don't think you're moving too fast at all. It gives us more time to talk afterwards and to hang out in the Discord.
All right. Okay. That's fine. I didn't want to overwhelm with lots of details, so I thought I'd go through sort of practically useful but not too overwhelming examples that I'm showing here. Okay, so I can move on. Yeah.
Well, actually, let's hold. I just somebody said that it's hard to know if they'll get the question in time. So we can pause here just for a couple of seconds just to see if anything else comes in.
Yeah.
But yeah, this has been very interesting so far, especially, there are so many things you can do with Python that sometimes I'm like, I feel like you can do just about anything. And sometimes
I mean, today.
Go ahead.
Yeah. Oh, no, you were going to say something. Sure. Yeah.
I was just going to say, like, sometimes, I need inspiration to know what you can do, and to see this, it's like, oh, like I know that there have been times in the past where I'm like, something like this would have been super useful. And now I know you can mess around with stuff like this in Python.
Well, necessity is a mother,
Indeed.
So, okay, I guess I'll just move on. This thing I found out relatively recently, I guess really a year ago, was, creating animated GIFs. And I would have never actually figured out how to do this, except for the fact that about a year ago, I started, going much heavier into documentation, both on GitHub, on, Atlassian Bitbucket, and on Read the Docs. And I found out, oh, lo and behold, if I put in my MP4 file in the, in that service, say Read the Docs, it's not going to, animate. Same with GitHub. And so, just a Google search told me, oh, yeah, they're not going to do that. But they do, read in animated GIFs. Hence, okay, how do I make, relatively high quality animated GIFs of MP4 files, or I haven't used it too much, but the functionality is there, of YouTube clips that I found, and turn it into an animated GIF that I can put, on these services and on these sites. So again, this is more, I really don't know how it's done. It's voodoo magic. There are much smarter people, at least in this respect, who've made the functionality work. But my understanding of it is, I thought I put it in there, but it's I think in the demonstration, I thought I put the URL in here. The first pass creates something called a color palette. I guess, it takes that image, that movie file you have, which is, I guess, a fixed size. At each frame, it's a fixed size, right? It has, n pixels in the horizontal and m pixels, a different number in the vertical. So, okay, that thing is fixed, and it, I guess, populates, it converts that into 256 colors, right? Because it's a GIF. And I guess it colors each pixel by the most common, color that was seen there among all the frames. And then on the second pass, it creates the actual animated GIF using that color palette, because the website, I guess, in the demonstration, I thought it was here too, says if you don't do something like that, and if your movie file doesn't have the frequency of colors of the standard palette, you get a bunch of, really crappy artifacts in your animated GIF. But if you do this, you won't. And, in my relatively cursory examination of that, I found like maybe the 20 or 30 different movies that I've created, following this prescription works. But don't quote me on other things that might work that would do the same thing. I'm just happy with, okay, it works. I don't have to think about it. It's reliable. Okay, so I'm going to use it. Now, the second functionality is really not all that different. I mean, there's just an extra step. The first one was MP4 to GIF, right? The YouTube to GIF is just a YouTube to MP4 and then MP4 to GIF. And the YouTube to MP4 path uses YouTube download to download this YouTube clip as an MP4, and then takes that sort of temporary file and turns it into the animated GIF that you want it to. And of course, deletes that temporary MP4 file. And there's actually a functionality. I should probably fix this because it was actually, no, I think it was using some functionality that it turned out not working. It's referring to that. So it uses this thing called NPR Stuff's convert images, other functionalities, this movie or YouTube, to generate that. And I'm actually going to demonstrate that right now. I guess we could, well, I wonder if this will work. Oh yeah, it actually does. But it's kind of, at this stage, you'd probably have to take my word for it. But this is, again, taking that movie file that I had and converting it into an animated GIF. It is high quality. It will, work when you put it on GitHub, which I do, but it's significantly larger. But if it's 32 megs in size, I figure really it's probably GitHub's problem and probably the person who wants to load the file in, at least look at the README. This other one, it's really a scene from one of my favorite, I guess, animated shows. It was only around for 2 seasons. But you can see it's sort of a little bit of banding. It is an animated GIF created from a YouTube clip, which I'll just demonstrate in a few seconds. Well, let's see. I guess we could go through this.
What show is this?
Lucas Brothers Moving Company. It's really made for people who who like to get high a lot, which I like because it's a part of my life that I can't really explore anymore. Actually, I also have the YouTube clip too, somewhere in there if you guys want to see it. But okay, let me just go through that thing I just was talking about here. Okay, this other demo. Let's go up one more. I guess we're going to movie GIF demos. So the functionality that I showed, creating an MP4 to the GIF, it's just located here. I'll just show that for you. One thing that I've just decided to do is, as I explained, if code is, or functionality or whatever is really hard for me to understand, I tend to editorialize. So that's sort of the comment I have here. This consists of voodoo FFmpeg magic that converts MP4 to animated GIF. Don't ask me how most of it works. Just be on your knees kissing the dirt grateful. I think that, what is it? Grateful that millions of people hack onto and into FFmpeg so that this information is available and that this workflow works. So it's just saying, I don't understand it, but I'm really grateful that people have told me how to do it and that it worked, that their instructions actually work. So it's basically saying, okay, going to this, I think, yeah, it's this website here. And I'll just show it for you guys. Honestly speaking, I don't really understand it. And this was just going in more and illuminating detail on exactly what this, how to make an animated GIF. Just define a color palette appropriate for the movie file you want to convert, and then go through the second pass to actually generate the high quality animated GIF. Because if you don't, you'll end up with something that looks more like this. At least, yeah. And this is really the code. And the code was my best effort to, go through the workflow that was described in that website. And a bunch of, temporary files, like the temporary palette color file, I think, which is a GIF or something. Maybe, yeah, I have to take a look, but it's probably buried somewhere in there. And then step 2, take the palette, create the animated GIF from that. And yeah, and I guess let me just show how that part works. Okay. Yes, okay. Let me go through that demo in that directory. Oop. Let's just go through this first one here. So, image movie. Yep, this is what it does. It takes a little while longer than the created MP4 from a sequence of images. And all the yep. And here it is, the animated GIF at 5 frames per, well, I think it uses the default frame rate. Yeah, by default, it uses the frame rate of the input file that was used to generate it. I decided, why make my life more difficult? This is just bog standard stuff that I wanted to do.
That's really cool. How do you get the shapes of like the I guess, I don't know if they're counties or the parts that fill
that
in?
was, yeah, that's the 2-week question or 2-week thing that I had to do. Was what I ended up doing is, created the county shapes and other data, like for instance the county index address called a FIPS code from U.S. Census Bureau. It was all there. There's also the problem that the New York Times database joins each of the 5 boroughs of New York City. It doesn't identify the 5 boroughs as separate county, which they are. It just says it's New York City. So that caused my code to crash sometime in April. Is what I had to do is figure out, oh yeah, they were joined, and change the code accordingly to do that. It's actually in the GitHub repo. The resources directory there shows, oh yeah, there's a lot of just nitty gritty that I had to collect to make it all work.
I imagine so. Yeah.
Yeah, it's just a bunch of corner cases. Turns out 5% of the counties are corner cases in one flavor or another. So I had to make adjustments around them, or workarounds around them. Yep. And let's go to that one. Let's go to this one here. This. This is this tool called YouTube-DL. I don't know if any of you've ever used this before, but it is quite useful. You do have to update the tool every so often, because Google changes what it does under the hood. But yeah, it first stores this temporary image as an MP4 file, and then a little bit slower, this is then taking that MP4 file and converting it into an animated GIF. And let's just open that up. Yeah. I guess it looks, this is the actual, size in the downloaded YouTube clip. And so that's what it creates. So yeah, I guess since you've seen this before, fine if I just close it up, since it's about a minute or so long. Well, I guess we could go through it another time, or one more time. All right. So one last thing I guess I could show is exactly where this stuff sort of lives. Let's see. Islam. Yeah. I want to show you an example here. So this is the COVID-19 tracker. You see these, so 1, 2, 3, 4 animated videos that I have. These are basically that functionality. Taking this sequence of images, or taking that MP4 file from a sequence of images and creating an animated GIF that I've uploaded to GitHub. And now my README can, when it links to that, it shows up properly. GitHub actually animates it properly as a web page. Oh yes, actually, yeah. 1, 2, 3, 4. Yep. So yeah, the data that I have is from a few weeks ago, because it takes time to update the documentation. But yeah. So I guess here it's I guess we could take a pause here if you guys are fine with that.
Yeah, sounds good. We've had no new questions, but there are a couple of comments. Essentially, somebody shared in Discord that YouTube DL is an open source project, and we had some comments about
Yes,
GhostScript, how cool it was, and all. Yeah.
The GhostScript is very useful. I just don't know really how to use it. I just use other people's scripts. That's where they get GhostScript to do what they need it to do, and I just copy that and wrap it up into my functionality, either as a command line or as sort of an API function that I could call from elsewhere.
Yeah. Cool.
Yeah. All right. I know we've been talking for about 50 minutes now. There's just one last part to it, which is also using YouTube DL. So if nobody has any objections, or they don't, if people want to move forward, I can move forward.
Yeah.
Okay.
I will let you know if there are any questions that come up.
Sure. Let's see. Okay, the last thing, I thought I wouldn't have time for it, but I guess since that functionality went away, we'll just move on. Is this tool that I'm using to, I hear something on Shazam, or, okay, this is a song I heard in some other context somewhere. A lot of times I listen to, CBC's Q by Tom Powers. So it's got a lot of really good music that I would not have been exposed to. But okay, I found that. Okay, this is the artist, and this is the song. Let me see what it sounds like. Let me see what the whole clip sounds like. And so, at a high level, this is really all it does. You identify the song and the artist, and it goes to this music metadata library called Music Brains, and queries has an API that queries that server to get to fill out all the metadata for that song. So that would be of course the song title, the artist, the album from which it came, the track number, total number of tracks, the year the album was released, and the album cover. And the audio it gets from YouTube, downloads from YouTube DL, but also the way it works is it gets that song, it searches YouTube, given that song title and artist, and gives you a list of 10 or more, clips that qualify. And furthermore, it also has the song length for, this functionality of those clips. And the thing to do is the command line tool will also tell you, okay, it found this song's metadata. One of the bits of metadata it found was also the song length. And so your job is to look at the high-ranking YouTube clips that whose length is just at the length of that song, if it's able to find it. Well, let's see how it works. Here's just a animated video of what it does. I guess, but this is basically what it is. It gives you the length. Okay, choose that song that matches it best. Conceptually, that's all that is, at least in its default state. So with that stuff, let's see if I can go through here. Let me just go through that final demonstration that I have. So the way it works, let me just, I don't want to say that all the code is, simple to design. There are three parts to it. The three parts are conceptually straightforward. The first part is, getting the metadata here using Music Brains. And let's see if I think I did it sort of the wrong way. Let's see, what did I do? I've got to probably fix this here. But let's see. Yeah, I'll fix this. I'll update this so that it's, actually correct. Yep, I think, yeah, this is it. Get music data. Get music metadata. Yeah, oh, sorry, it's supposed to be this line here. But this is really what it does, is it queries, the Music Brain service, and given the song and artist, it'll, return this kind of data structure, this JSON, this dictionary, with all the relevant data, metadata for that song. The album, artist, year, track number, total number of tracks, the actual song title, the correct song title, which is, if you've done it the right way, is the song title you gave it, the duration of the song that it found, and the album URL that you can then download. And of course, it has some kind of error functionality in there. Let's see, hopefully this is correct. So this is, you saw, in that video, it did this YouTube search, right? That is, given the song title and artist, it gave you a list of YouTube clips of the highest rank, I think up to 10 in this case. And with those named clips, it also gave you the length of that clip. And so that's just an easier way, or a more unambiguous way, to identify, okay, is this clip actually the one I want, rather than, something else. I found it works probably 99% of the time, both the song title and the length of that clip. If they both match 99% of the time, it works. There are very few false positives. So that's that functionality there. This is have any of you guys used any of Google's services, like Gmail, Contacts, YouTube? Basically, they're all exposed through, a Python or really RESTful APIs, but with, say, Python wrappers in front of them. And the authentication occurs through, OAuth 2 authentication. Even after a few years of doing this stuff, I don't really know the nitty-gritty of how it all works, but I've sort of hacked together a prescription that, based on what I've seen other people do, and just through trial and error, discoverable trial and error, I found something that, does what I want it to do. So yeah, this says, okay, look through and, find the videos, find the selection of clips that you want. And the third part, let's see, go to that one, is this part here. Hopefully this is
while it's loading.
Location.
Have you seen many false positives with song covers?
It's actually fairly rare. It happens a lot more with much more obscure songs. Like if this artist hasn't released something commercially, if they're still, under the radar, so to speak, then yeah, it's a lot easier to get false positives or relatively little coverage of the songs that they put out. But for the popular ones that, have record labels behind them, it almost never happens. Or actually, I can't even think of a case where it has. So the example I'm giving you is by this French electronic band called Air, and it's also one of their more popular songs. So there's been like zero problems with cases like that. But yeah, here's actually an interesting point. This functionality here is also the same one that's used, underneath the hood as the convert image, taking a YouTube clip and converting it into an animated GIF. This is the part that says, okay, in some fashion, use YouTube DL as an API to, convert it, or at least this part is, I should say. This part is, it takes this part of course, uses a different format here to take, that YouTube clip and, download it as an MP4 file. But yeah. And this is, this is really the thing that says, okay, take that information and download it into an M4A, music file. And let's see if this works. It's one of those songs here. This might take a while, so with this, I guess I'm just waiting for it to actually, find the metadata and then, have me choose and then download it. Well, so with that, do you guys have any questions right now? This is basically all I have to discuss.
There was one other question that came in about going back to the cropping of images or kind of dealing with images. Have you ever done something where you're looking at a graph and you pull it down and you're trying to get the data out of the graph?
Oh, no, that's a different, different idea. It's also very useful. I just haven't gotten it to work, but it's basically, pattern recognition or feature identification, right, at a low level. Mm-hmm. OCR is just one flavor of it. I haven't actually looked at it in any great detail. What I've really done is, taken plots that have been digitized and then say identify, the coordinates on the axes, right? So that now and also where necessary, identify points on the scatter plot to convert that, okay, something in pixels to actually my best estimate of the data that's being plotted there. But I haven't done anything more sophisticated like, at least, myself making tools that I do, because I haven't done it that often, is say, okay, I have code, right? It's been digitized and scanned and put into a PDF, right? Is there a tool that can, with great fidelity, convert that into text as, a block of code that I can then, clean up a little and then put into my files? I haven't done anything like that.
Yeah, I imagine it would be pretty challenging. Yeah, especially like you got to have a really good resolution image and, everything's got to be just right in order to be able to pull data out. But I imagine you can, mess with it or fudge with it.
Yep. I guess Tesseract. I've actually tried Tesseract a few times. I haven't had great experiences with it, but who knows? Maybe I'm just unlucky. Or I tried it also a few years ago, so maybe it's improved a lot too. I just haven't used it all that often. The last time I think I used okay, here's a scan. Can I then use a tool? I think I've used Adobe Reader or something like that to convert that, stuff I've scanned into text. And the last time I did it was probably two or so years ago, 2 or 3 years ago, actually. So, yeah, I haven't done it that often. So I can't, to be fair, I can't honestly, faithfully comment on how good or bad these tools might be. I knew this would fail. So we're going to actually use something else. Let's see. Or the interesting thing about this tooling, and it's in that Git repo called Plex stuff, is there are 3 metadata services that it can use. By default, it uses something called Gracenote. The problem with Gracenote is it doesn't have all the metadata. For instance, it doesn't have the song length in there, or in a lot of cases, either the total number of tracks or the album image. But it tends to work the best and quickest, but we'll see. So this is what it does. In this case, you choose the clip that, okay, I don't know how long it is, but what it does is it creates that. Oh, I guess I don't have this thing called Mp4 Info. It's also, Mp4 Info is one of these tools that are used to give you information on, Mp4 files or, video files or M4A files. It'll just give you the metadata there just to check that it works. I guess right now, you might have to take my word for it, or we can, in chat, go into more details on that. But that's just an example of what this tool does. And I guess with that, at the final part, I have 4 links to the presentation on exactly where all this stuff comes from. So if you guys want to take a closer look or a deeper dive, you could go to these 4 separate places. And also, I guess the presentation and demonstrations are also on GitHub, on that Git repo, whose link I just sent in the Discord chat, and that I'm showing here. So yeah, you could also go there to get information, everything that I've talked about here. And yeah, I guess that's what I have to talk about. Yeah. Anything else, or I guess we're good?
Yeah, I really appreciate it. I'm so inspired to try out a bunch of different things, and
all my stuff is BSD2 licensed, so have at it. Just chop away whatever you might need, and even if I have time, I'll also even answer whatever questions you might have about exactly what it does and why it does it that way.
Yeah, awesome. I'm waiting just to see if there are any more questions that are coming in. So far, there isn't. But thank you so much for coming out tonight.
Oh, thank you for having me. I know I asked several times, and thank you for accepting my volunteering eventually.
Absolutely, yeah. It's we were I was so thankful, because most times sometimes it's hard to find people who can fill in, and so I was very happy that you volunteered and wanted to be a presenter.
You're welcome.
Excellent. Well, I guess that's about it. There are a couple thank yous coming in, and as far as the rest of the evening, we are going to transition over to the Discord server, unless anything else comes in these last couple of seconds, which I think one more message coming in. Once again,
yeah, it's coming in both. It's coming in both in the StreamYard chat and a little bit also. Well, mostly in the StreamYard chat, right? I haven't seen so much in the Discord, but I guess Discord is for later, right?
Yeah, exactly. That's what I was thinking.
Okay.
But for those who are tuning in to YouTube, we are going to have a coding night, as I said earlier, July 23rd. And then our next lecture night will be August 12th, back here on YouTube and in Discord. I would imagine we're trying to figure out how things work with YouTube and Discord, and how we're going to go going forward. But it'll be announced on Meetup. Otherwise, yeah, everybody says thanks. Great presentation. That's exciting. I think we got a lot out of it. So I imagine we'll see everybody in Discord in just a moment.
Okay, cool. Yeah, so I guess I can get off StreamYard and go to Discord, and hopefully it'll work.
Actually, before you do that, if people have questions, and it's 2 weeks from now, and the Discord's whatever, how can people find you online and reach out to you?
I guess if Discord is down, do people go on the PyRVA Slack channel or Slack? Or
absolutely. There's definitely the PyRVA.
I'm always there.
Okay, cool.
Yeah, so I mean, it's always on there. So
excellent. Are you on Twitter or anything like that?
I do have a Twitter. I don't use it all that often. I do always get notifications for the Slack, so that might be the best way to get me immediately, I should say.
That sounds great. Cool. And if you're not on the PyRVA Slack channel, you can go to pyrva.org, and there's a way to sign up there.
Okay.
With that.
Oh, you mean to sign up for the Slack channel and everything like that?
For people who are who may be watching this video later.
I guess you could email me too. I mean, if nothing else, I didn't remember. Did I put my email address in the? I probably should have. I guess I could. I'll fix the presentations to have my email address too in there.
All right, sounds great. All right.
So, yeah.
Well, thanks again, and we'll catch everybody in Discord. Bye.
All right. Okay.